Hello, yet another of my A-level physics multi-choice questions. If you want to try to answer this question yourself, please pause the video now. If you got the answer C, well done. If you didn't and want to hear my explanation, please keep listening. So, when a parallel plate capacitor is connected across a battery, the energy stored in the capacitor is W. The battery remains connected as the distance between the capacitor plates is halved. What is the energy now stored in the capacitor? So we've got a cell or a battery, and that is connected to the plates of a capacitor, and those plates are going to move closer together. And how's that going to affect the amount of energy stored in the capacitor? So two equations we're going to use to help us answer this question. The first one is that the capacitance is equal to the area of overlap of the plates multiplied by the permittivity of free space multiplied by the permittivity of the dielectric between the plates over d, the separation of the plates. And in this particular question, d is going to be the important part. That's the thing we're changing. So the first thing I can see is if we halve that distance, I'm going to double the capacitance. So the capacitance I'm going to end up with is going to be 2 times the original capacitance. How does that affect energy? Well, we've got another equation given on your data sheet that the energy stored on a capacitor is equal to a half multiplied by the capacitance multiplied by the potential difference squared. Why did I choose that equation? Because there are a number of equations that give you energy for capacitors. I chose that one because the voltage is going to remain constant in this particular case because all the time it's attached to the battery. So if it's a 6-volt battery, then at the end we're going to end up with 6 volts across the capacitor. So we can see that energy is proportional to the voltage squared, but we're not changing the voltage, but the energy is equal to half the capacitance. So if I double the capacitance, then I'm going to double the amount of energy. And we said the original energy was W, so I'm going to end up with 2 times W. I'm going to get the answer C. I hope that was useful. I hope it gives you A-level success. I hope you tell your friends. I hope you subscribe. Thank you very much for watching. Please watch more in the series.